Anybody can encrypt any message. Welcome to Rusty Science. What if you want to share some super secret information to your friend? Either you'll go by person or maybe you will send through somebody else, right? What if that person is not trustworthy or maybe he will deliver the message wrong? In that case, your super secret will get revealed, right? To avoid that, you may have some sort of a code words only your friend can understand, right? That is the shortest form of encryption. Anybody can encrypt any message. Okay, this encryption is not new. We can see this kind of encryption from Stone Age onwards. Lot of scribblings and lot of doodles which we are not able to decipher even till today. There is one of the best example for that is called Phaistos disk, which is from second millennium BC. It had a lot of doodles we are not able to even decipher with our current technology. Apart from that, one of the well-known encryption techniques is called Caesar cipher. 100 BC, Julius Caesar was using this Caesar cipher for sending his military information to his other troops. His technique is very simple. He used to take the alphabet, shift certain characters either on the right side or on the left side, and he send it as a message. I'll show you how. Okay, if you consider this as a Caesar cipher, okay, you can clearly see that the Z will represent, X will represent A, Y will represent B, Z will represent C, and so on. For example, you can see three characters shifted right. So this kind of a shift he has actually used in his encryption. With this Caesar ciphering, if you want to write rusty signs, okay, RUSTY. If you want to cipher this rusty signs, you can see from the sheet. R is going to be Yo, and U is going to be R, S is going to be P, T is Q, Y is V. Instead of sending rusty signs, in case if I send a message something like this, it will be really difficult for you to find out that I'm just trying to say rusty signs, right? This is called Caesar cipher, and this shifting is not always fixed. Only whenever he sends, only the person who sends and receives will know how many characters shift, whether it's right or left. If you are a 90s kid, you obviously know in our childhood days we were playing with some shifting. Okay, this is a sheet we have used. It's called old school cipher because I named it. Okay, so we arrange the characters in certain way, A to Z in this format, A to R in square matrix, and it's in the triangle matrix. Okay, in that case, whenever if you want to say A, you will write it as the red symbol. Okay, if you want to again shifter it as rusty signs, R is here as a second character. You cannot put the symbol, but there is an easy way for it. Okay, I'll just write it in red. It will be easy for us to understand. This is Q. Then if I add a dot, that represents the second character. Okay, U, here it is. Instead of saying rusty signs, using our old school techniques, we usually send it like this. So it's very easy. But only people, those who knows this table, can only decipher. But the interesting part is we generally don't follow this A to Z format. We used to randomize inside the character. So if somebody have this technique, how to do it, they may not be able to decipher it because we used to jumble the words across. He will take the sheet in their hands and they used to decipher it. In that case, even if they know what kind of format I'm using, what kind of a pattern I'm using, they will not be able to decipher until they know each character where exactly I have placed it. This is called old school ciphering. Okay, but whether maybe a Caesar cipher or old school cipher, there is a problem with this because it's with the English language. If you take any English paragraph or any sentence, you would probably notice compared to all other characters, character E is the most often used character. In this case, if you take this as one of the formula, then obviously you can see it like take the whole paragraph and find out which is very often used symbol. You consider that as E, and then some of the other rules, like in the sentence, if two letters are alternate adjacent to each other, then it most probably may be L, because shall, will, all those things we use two L's. And if you remember Q, if you are using the next character must be U. In case if you find out Q, then you can easily find out what's U. In that way, if you one by one, if you are able to easily figure out based on the arrangements and the character distribution, then it's not very difficult to find it. It's like hangman puzzle. Easily you can solve most of the characters. Remaining, you can easily guess the word. But still, deciphering these kind of encryption is really hard than we anticipate. We have one more concept which is also often used in World War II time, which is called Cipher wheel. Okay, I have made one for you. Okay, this is a Cipher wheel I have created. This will serve as the last disk, which is character disk, which can help us to identify which character we are trying to write. The remaining four disks will try to randomize it so that the character will distribute even, as well as some sort of the other check mechanism we can use it. Okay, let's see this, how we are going to separate. If I take the same way, I'm not going to write a full word, I'm going to write hello. First, initially you just spin it as much as possible. So however you want to spin it, you can spin it. This is your initial position. Okay. Once you have completely spin, you should not change it. Okay. You can take one of the characters, a reference character. Okay. I'm going to take dot as my reference character. Okay. I have taken dot. With respect to dot, what are all the characters I can find? Okay. Just have a look. Dot, U, Z, and then 11, also Roman letter, and 5. This is my initial position of the disk. This is very, very essential, otherwise the other person cannot do iron shift. Okay. The second thing is each disk will have one unique number. Okay. I'll show you that. This has R1, R2, and it has A1, A2, nothing but like it's a Roman letters, so R, it's a alphanumeric, so A, it's a original disk, so O. What I'm trying to say is these numbers is very essential for us to note. Okay, I'm going to write 0, 1, A2. You can give any number. I'll tell you why this is essential. R2 and R1. So now two major things we are noting down here. First one, our initial position, and second one, what are the disks we are using. This is the arrangement we have. Now I'm not going to move it. Now what are all the characters I find? For H, I have A, F, R, in Roman letter 1 and 9. This is going to serve as my H. Then for E, the same way, I'm not going to write E, but this is P. Now I want to make some random, so I'm going to add E, J, and 3. I already mentioned that there is the error correction, right? In case instead of 3, if I have written this as 6, okay? While you're decoding it, you will try to find where is E and there is J, and you're trying to write 6. There is no way 6 is getting matched. That must be a wrong character. You can easily identify. Instead of J, if I have put like L and I put something here, right character 3, then I find E and 3 is there, but what happened to J? So this is the wrong character. I can easily eliminate the errors there. Okay. Then finally O. O is here, which is nothing but H, M, 4 and 12. Okay. If I send this as a message, instead of sending hello, if I send these characters, these letters to some different friends, if he has the same ciphering rule, then he can easily figure out what the message you're trying to say. Now let's come back to why I have mentioned you to add this. Here you can see there is English characters and some Roman letters, right? I have one more disk, okay, which has Greek characters and some different numbers, okay. I have named it as R3 and A3. Instead of instead of A2, if I'm planning to use A3, then I would just mention this disk. Instead of R1, if I'm planning, sorry, R2, if I'm planning to R3, then the disk will be totally different. So even if you send this message, if the disk number is wrong, you will try to put a different disk and you may not be able to exactly decipher what you are trying to say. So it's very essential for us to differentiate what exactly. What I would suggest is, if you just completely write it one by one, you can add some sort of a character, for example, dollar symbol here and hash symbol here. Whenever the user sees there is a dollar symbol, that means it's initial position. Whenever there is a hash symbol, that's going to be disk change. So you are going to cipher it continuously. Okay, then I said, okay, hello is done. I'm going to write like rusty. I'm going to completely write it in a different way, so I'm just changing it completely. Now my initial question is going to be yeah, okay. In that case, what I can say, the user has to be notified saying that I have randomized. So now I'm going to put one more dollar symbol and I'm going to write FXG37. Okay. If he sees the dollar symbol, he immediately he'll realize that okay, he has randomized it. So again, he has to change the speed. And in the same way, this ciphering is done. I want to change my disk in between something so that the character will be much more random. In that case, you will take some disk out and you'll add new disk. At the time, you're going to add some hash and you're going to add new disk numbers there. So in this way, what exactly we are trying to do is we are trying to randomize the same E. Once you change the dial, once you add the dollar symbol, it's going to be completely different. Once you change the disk, it's going to be completely different. Simple way is, earlier we had a drawback, right? Like character distribution. That issue will be completely ignored with this cipher disk. Encryption is really a fun. You can do a lot of things with encryption and you can play around with, but it has to be very carefully done. In 1912, wholesale seller, he bought a book and he found it's completely in different language. Nobody was able to understand what exactly it's done. They finalized that it's actually some encrypted message. They carbon dated it and they found it is somewhere in the mid of or beginning of 15th century book. And it has a lot of weird looking doodles of planet and stars and plants on different organs, and it's really weird to see, and nobody was able to find out what exactly the book says. The book name is called Voynich Manuscript. Okay. The problem is nobody was able to decipher it, and it may have some valid information, but unfortunately we are not able to find anything out of it. If you are encrypted, and you should make sure your end person who is about to read it should know how to read it. If you are not able to reveal it, then whatever be the information you put there in the book, it's completely waste, right? Even some speculation says that that book is some sort of a hoax, because in the 15th century, people are looking for knowledge and they wanted to invent something new and they want to win the race. In that case, these kind of some encrypted nonsense, they have somebody written it and they just might have sold it, right? In other way, some people say that hey, it's some intelligent life form has brought it here, or some aliens brought that book here. So it has some valid information. Whatever it be the case, if you're not able to decipher it, then what's the point of keeping it? But the good thing is, somehow I got hold of that book. It's not an original book, it's a PDF format. If you are interested to decipher it, and if you are interested to see that book, you can go to our website and it's in the resource section. You can find this book. It's free of cost. You can download it and try to decipher it. Okay, but the encryption has a lot of advantages as well, because in the Second World War time, a lot of countries, like almost whatever be the countries participated in the Second World War, were highly using encryption. Germans were using some of the higher end encryption technologies, which even when I read the article, I was literally surprised that such a kind of imagination they had. I have written all these things in a blog post. I don't have time to explain all the things, but yeah, if you're interested, I highly recommend you to read the blog. I have given a lot of reference links to it. Okay, And yeah, finally, as I mentioned, this encryption is a lot of fun. You can play around. Only rule is when you're sending one encrypted message from you to your friend should know how to decipher it. If he knows it, it's a lot of fun. If you don't know it, it's garbage. Okay. And I highly encourage you to try something with these kind of cipher wheel, and just it's a cardboard. Just take some cardboard, cut it out, and try to do your own doodles. Just share with us in the hashtag Rusty_DIY. Okay. If you share it, I will definitely have a look at it. Maybe I can show it in our next video, or maybe I can post it in our social media pages. And yeah, that's all I have. If you have any interesting story about encryption or you just had fun, I highly encourage you to post it as a comment. I'll read it and then try to answer it. Thank you.